Yeah, hi everyone. You're welcome to Ansible Toronto um, virtual meetup. So the group has been in existence. The meetup group has been in existence for probably 5, 6 years, but was should I say was on vacation shortly after COVID. And then I was just a member, and then I signed up early on this year to become a co-organizer of the group. And so this is our uh, first meetup. So we're just trying to get things started virtually, and over time we would move to um, physical meetups. So we have a couple of um, should I say, people in different enterprises that have signified interest in hosting us. And if you feel this is something you can do, you can easily reach out to me through my email. This is all a volunteer effort, so we're just trying to get everyone to pitch in as much as possible. I'm aware there are other user groups that are actually quite functional. There's a Grafana group that I attended a couple of weeks ago, and there's one for HashiCorp user group. So there are user groups for AWS, for other cloud-based providers. So, but the idea is to get people together to get the usage and to get the knowledge and the experience people gain by using the Ansible tool in their workplaces and for their projects. The idea is to get the knowledge widespread, and also to get suggestions from people on what topics they want to hear about. So we'll be kicking off the very first meetup presentation. Like I said, this is the very first in like 3-4 years. So hopefully once we get things going over time, we'll have more people join in, and then um, it'll be the more the merrier. All right. So thanks a lot. I think I would let me give sorry, I'm just trying to pin. Yeah, so Dan is from Consensus Enterprises, and we're thankful that he volunteered to be the, should I say, to be the prototype, or to be the proof of concept for this virtual meetup. Yeah, thank you, and over to you. Sorry, Dan, can you? Sorry, Dan. Um, Dan, are you there? Oh, sorry. Okay. Okay, I invited someone else to unmute, so let me uh where's Dan? Now I have to get Dan to unmute. Apologies for there's Derek Evelyn.
Hello.
Yeah, apologies for the yeah.
Don't worry. Is there any chance I don't mind people seeing my face? Can I be allowed to turn my video on as well? I'll probably also need permission to share my screen.
Oh, okay, please do all of that. Yeah.
So I'm not able to start video. The host has
To start a video. Oh, okay, 1 second. Let me allow make co-host, allow to rename chat mute view profile. Okay, so let me allow okay, host tools. Start Okay, so can you start the video now?
Look at that. I'm a real person. Hello,
Yeah.
everybody. Thanks very much. It's Olu, right?
Yes, yes,
Yes.
it's Olo.
Olu, I haven't.
Yeah.
I think we actually. I think I was at a couple of the meetups before
Okay.
COVID, or at least one. I remember,
Okay.
and I remember meeting you. But it's been a while.
Yeah.
And I'm glad to see some faces I know from Consensus, where I work. I see Christopher, I see Scott. I feel like I'm on Romper Room.
Yeah.
But I also see some folks I haven't seen in a very long time, like Derek Evelyn. How you doing? It's nice to see you. You probably can't unmute. But anyway, it's good to be here, and it's good to have an audience. Um, I want to talk a bit about some work that we do at Consensus and have been doing for a while. I'm going to request presenter abilities because I can't present yet. There, now I can. Let's see.
Mhm.
Okie dokie. We're just going to share my desktop. So it's great to see everybody. I'm going to say allow. Can you just let me know if the sharing isn't working?
It is working.
Okay, great. That's good to know. And I'm just going to look at a couple of things. So, what would be nice is if I had a very slick product demonstration to show you today. I do not. This is a presentation intended for a technical audience about why some of the things that we do at Consensus with regard to an open source project that we run called Rugged, what they have, how they use Ansible, and why they're cool. So hopefully, the assembled audience will be able to follow along with that. So there'll be a bunch of code, and you'll be looking at a terminal quite a bit. That said, before I get into that, I do need to position things a little bit and explain who we are and what we're up to. So, Consensus Enterprises is a consulting group that I'm a part of that works with with a variety of different customers. We do a bunch of different things. This is our website and our logo. It's at consensus.enterprises. We consult on we do a lot of cloud consulting. We do a lot of automation work, a lot of DevOps stuff, and that's my particular area of expertise. The other thing that we do a lot of is work with a CMS called Drupal. Um, I'm going to assume that folks have at least heard of Drupal and know the kind of thing that it is. Um, I'm happy to see if there are comments in the chat saying, no, we don't actually know what that is. I'll pay attention to that as well. So I see we also have a couple of my colleagues from Consensus on the call today, which means that there are plenty of people here to tell me if I make mistakes or get anything wrong, and that's also very exciting. But for the moment, to speak a bit about what Rugged is, I have to explain a little bit of background. And for that, I'm going to use some slides that my colleague Christopher, who's Rugged's lead architect and is on this call, prepared for DrupalCon Barcelona last year. So basically, Drupal as a CMS has been around for 20 odd years. It occupies some non-trivial percentage of the internet. I think it's 1.5% of all websites on the internet, which is a very large number, are running Drupal in some way. Recent initiatives in Drupal include an initiative to re-engineer Drupal itself so that it can update automatically in an unattended fashion on large scale infrastructure. And this initiative was coming along around the same time as we all started hearing about various kinds of software supply chain security attacks. Most recently, probably NPM is the most famous example. And a supply chain security attack is simply, if you think about it for a sec, we are all downloading lots of software all the time in the open source universe, whether they are NPM packages, Composer packages, which is the sort of an equivalent for Drupal. There's pip for Python. There's Maven for Java. There's all kinds of stuff. And so with these software packages, you're basically downloading arbitrary software and running it on your computer. As the, let's say, attack surface of that has grown, as more and more code is being downloaded by more and more people around the globe, it becomes more and more appetizing to people who'd like to interfere with that process to insert malicious code into those kinds of workflows and downloads. So a lot of people have done a lot of thinking about this problem for a long time, turns out. One of the groups of people is a group that has something called the Update Framework, or TUF. And basically this, if you think about it, is it's called a supply side attack. And tough, it's very complicated. I don't know it very well, but it's an initiative that allows, it's basically a standard for how to implement systems that will be engineered to try to mitigate these kinds of supply side attacks. And in particular, at Consensus, we've been working with the Drupal Association, who are the folks that distribute Drupal itself, to implement Tough in a product, in an open source product that we call Rugged, or the Rugged Tough Server. The slides that Christopher did last year talk a little bit more about the kinds of processes you would want to do in a Tough server. The specification is very particular and very detailed about signing of metadata for software packages, making sure that the packages you download are have integrity and they're fresh. And there are various adopters, including the Drupal Foundation themselves, who I believe are currently beta testing this with real life users, which is very exciting for us. Um, the part that's going to be interesting about this to an Ansible audience, though, is not understanding what Drupal is, or understanding even quite what Rugged itself is, or knowing too much about Tough. Um, for me, as someone who's very interested in Ansible, the part that's interesting is how we use it within Rugged. And so I'm just looking here. So there's all kinds of things about the future, which we can talk about, but the part that I want to talk about has to do with the rugged code base itself. So what I'm going to do is take a look at a little bit at the rugged code base. I'm going to show you why I think it's cool, the way we use it with Ansible. And then I might also show you how we build our development environments with Ansible, because that's part of the same process. So what you're looking at here, what I'm about to show you on my terminal screen, is a fully baked development environment that we've spun up with Vagrant and Ansible. That's running, that has the rugged code base checked out in it. I'm going to my screen. And this basically, if you think about it on the cooking show, is like when the guy on the cooking show takes a turkey out of the oven that's fully prepared and says, well, here's a turkey I put in the oven 5 hours ago. And so what you're seeing here is a fully prepared development environment with the rugged code base checked out in it. Maybe if we have time, I can talk about how I did that part, because we use Ansible for a lot of that as well. We integrate it with Vagrant and DigitalOcean. And it's kind of a neat process in itself that is separate from the other topic that we're talking about today. Now, rugged, as you can see, is a pretty typical, is actually, sorry, not a very typical project, because it's not really a Drupal site. It's not really a Python project. It's got a whole bunch of different things happening at once, and so that's what makes it kind of interesting for a developer. And I would invite, because this is open source, anybody who's interested to come and take a look at us. The project's at gitlab.com/rugged/rugged. There's a README at the front. There are some pipeline tests you can look at, and there's also a documentation site. The documentation site, just to quickly show you, um, has a pretty nice introduction, and has some more information about the sort of security concepts behind the update framework, that were also written by Christopher, uh, like this great article, Tough for Humans. If you're interested in software update security and software supply chain security, I strongly recommend you read this article. But we don't have time for that today. And that's not quite the part I want to show you. What is all you have to know to follow me on the Ansible part of this journey is that we use a lot of Docker containers today, we use several different tools, including Docker and also a HashiCorp tool called Packer, in our creation of those Docker container images. Those images in turn eventually get used in the Tough server to run various long-running processes that are called workers, that are managed by various other processes that we've scripted or that we've automated with Ansible. There's also a message queuing system that is uh, uh, a RabbitMQ instance. Um, so to build a rugged server, to basically instantiate this, means building a whole bunch of Docker containers. The building of the Docker containers, which is what happens inside this build directory here at the top level mostly, is the part that I would like to focus on within all of this context. So we've started with the big picture. We've sort of narrowed things down from the whole internet to Drupal, and the whole problem of supply chain security, and then from there down into rugged, which we're offering as a solution, and then down further into some of the components of rugged, and in particular the Docker containers. So with the Docker container, or with rugged, in order to build our Docker, in fact, sorry, before I go further, I'm just going to stop. In terms of the stuff I've talked about so far, thank you, Scott and Serena, for sharing the rugged.works site in the chat. I just want to know, from a context perspective, before we get into, okay, how do we use Ansible in this thing and why is it interesting? Are there any questions on any of that contextual information? And I don't know how to see questions.
I believe we all have access to the chat, so
Uh-huh.
yeah,
So if I see
yeah,
questions in the chat, so if there are any questions, thanks, Ovu. If I see any
yeah.
questions in the chat, um, now's your chance to ask me anything you want about the context. Are folks sufficiently familiar with, for example, what Drupal is, and the notion of supply chain, software supply chain security generally? Are people sufficiently familiar with what Docker is, at least, for me to go on? Seems like they are. I don't see any big questions. No red flags. Great. This is going to be so much fun. So basically, if we look inside of these three directories we have inside the build directory, we've got an Ansible directory, a Packer directory, and a scripts directory. The main, I guess, tool that we're using to create the Docker images is Packer. Packer is a HashiCorp tool, again, worth looking into if you don't know about, which allows us to specify the kinds of things we want to be in a Docker image through JSON files. So this is maybe an alternative, if you will, to the usual Docker file way of building a Docker image. We have a base worker image, and remember I spoke about some of the other workers that inherit from that image. We also have an image called the packaging pipeline, which is the one that I guess does what you might think of as the principal function that a tough server would do, which is to generate metadata for packages and then distribute it along with the packages themselves so that people can verify that the package they downloaded is in fact the package that they want and hasn't been interfered with anywhere along the way. That's what these do. So I'm going to show an example by looking at the base. The base image um, has the usual, for folks familiar with Packer, syntax in JSON of explaining that we're going to be using Docker and what our root image is. We're just inheriting from an Ubuntu container here. We've got some post processors that are going to run various scripts that we've designed to put the dependencies that we need onto the container. That includes various tools like Python and other stuff that are going to allow us to then, for the worker to do its job. And we also have some configuration for how Ansible is going to run on the container and where we're going to be pushing the container to once the container is built. For the example that I'm showing today, rather than using one of our public-facing Docker registries, I've set up a local Docker registry using the standard Docker registry local container. And you'll see there's an environment variable that I'm setting to set that. The so we have several types of, I'm just getting the chat out of the way. We've got several types, like I said, of Docker containers that we build. We also have a directory that has the various scripts that run, and these are all just shell scripts that do things like, for example, calling other scripts or initializing various apt packages or making sure we have all the dependencies that we want and so on, setting out open SSL or PHP, Python, etc. Again, interesting, but we're not at the Ansible part yet. So in the Ansible directory, we have a whole bunch of fun stuff. So we've got a different playbook for each one of the types of containers that we're building. We've also got some roles that themselves will allow us to manage the various dependencies, files, scripts, tools, etc., that we want to have on the various types of containers that we have. So far, so straightforward, right? In these, this is the sort of standard layout for any, Ansible role. You'll see that we're basically configuring where we're going to be putting things, um, how we're going to be mounting various file shares and stuff like that. What we then do is we invoke Ansible over and over again to build each one of the types of container and push it to our Docker registry. We do that with a makefile that's fairly complicated and that uses a whole other suite of tools that we have for makefiles called Drumkit, which you may hear me talk about. But all you need to know is it's a bunch of makefiles and it works for now. And anyone who wants to throw the link to Drumkit into the chat, in fact, I will do it. It's really easy. So Drumkit is, again, sort of a meta tool that we're using here. I'm just trying to think of what else I want to point out. So there are various, right. So the main workflow that I think is kind of neat from an Ansible perspective that I think is worth sort of talking about more is that once we build the containers using these playbooks, we use the workers role, I believe, or is it the scripts role? Now I'm just reminding myself where that is. 1 second. So, Christopher, if you're available, what I'm trying to remember is where the Ansible tests are. And off the top of my head, and I also have too many windows open. Trying to move some windows around. And head back to the top. The place I want to find them.
Hi. Hi. They're under
Hey,
each of the roles. They'll have a test.
that's what I was
Rugged
hoping.
workers. Sorry, the other one. Rugged workers.
Yep.
And then under tasks, there's a test.
Tests. There we are. All right, thanks. So the key principle and the pattern here that I think is useful to other people, which is why I wanted to present it at a meetup group. I just want to step back for 1 second. Often when we're using Ansible or any kind of automation tool or anything for any kind of deployment work, people tend to focus a lot on making sure that they can automate the deployment of whatever piece of software they're deploying or building or the artifact they're creating or whatever it is. And there is often, when people talk about tests in this context, there's a lot of focus on unit testing. Developers love unit tests, where they're testing the code that is going into the product that a process like this would then be producing. What I see a lot less of are post-deployment or post-build verification tests. And I think that that's really where this pattern shines. It's something I don't see enough of because it's something I always feel like I wish we had more of. It's something on any project I'm on, I want to make sure we're building it. The reason we want to be building verification tests makes sense from a very straightforward perspective, right? You want to be able to know that the thing you think you just did actually accomplished the thing that you think you just accomplished. Did I actually build the thing I think I just built? Did I deploy the thing I just deployed? Or did I accidentally deploy the wrong thing? Does it actually work now that it's been deployed? Or am I about to get paged or called by people telling me it doesn't work? Um, a great way to alleviate that kind of anxiety is to have a set of tests that's as simple as possible that runs right after you do the task that you're trying to do. In our case, with this example, the pattern, the task we're doing is just building a bunch of Docker container images. So we can't test an application that's already running. We don't have a running tough server that we are building as part of this, which is itself quite a complicated thing involving lots and lots and lots of containers. What we do have is the container we just built. And so, for example, what we can do is run our worker container and then ensure that it is actually that all of the things that what we can do is write down all of the things that we would want to be certain about right after we do that deployment, right after we do, in this case, the build of a container, right? Does the supervisor service actually start? Did the startup command actually run? Once it's run, does the startup log actually exist? Does, right, do these log files exist? Can I print them on the screen? Can I look at the various different results? It's very helpful to have a structured way to codify all of the things that one would want to make sure happened with each one of these target artifacts, right? And so Ansible providing this playbook mechanism, right, within a role means that we can iterate through all of the different types of container that I showed you before, those different Packer files. And if there's whenever there's a corresponding set of tests to run, right, we can run. So we sort of are using Ansible two ways. The first way is to actually build the container in question, and then immediately afterwards, launch that container that we just built and run a set of tests against it and make sure that it actually works the way we think it does. I'm going to show you an example of that now. But right before I do, is the thing that I'm describing making sense? Are there any questions? Gonna look in the chat.
Okay. So I guess I'll just ask a question.
Go
So
for it.
basically, the typical Ansible setup is you're looking at the hosts that are being
Yes.
configured. You're looking at the inventory, and then you're looking at the playbooks and all which is included in the role. So I understand that you're creating containers. So would it be a local host scenario in which you're spinning up the containers, right?
Yes, so
Or
you are spinning the containers up on localhost, but
okay,
once the containers are running, we treat them as if they are remote hosts. So there is
okay,
some sort of dynamic inventory management that has to be
oh,
done there.
okay,
Lucky for us, a lot of that's actually handled by Packer. Packer itself has a Docker plugin and an Ansible plugin that allow us to effectively not have to worry about that part mostly. What I'll do is I'll show you a simple example, and you'll be able to see that it actually does exactly what I just described. So so here I am on my Vagrant environment. I'm about to write, if I run make CI images and I tell make that I want this local uh, uh, Docker registry to be my registry, what it'll do is go through all of the images, right? So what I'm going to do is say, I'm going to use a make dash n. And what make dash n does is says, tell me what you're going to do, but don't actually do it. So you can see that we're going to make sure we've got our own Ansible dependencies installed. We're going to log what our container registry is, and then we're going to run through all the different container types that we want to build. And each one of those is that make-s invocation, which is what's called a sub make, right? So each one of these is going to be a different container type, and each one's going to have its own tests. What I'm going to do is, instead of running all of these, because we'd be sitting here for 10 or 15 minutes, I'm just going to run the first one. Okay, that first one is the base worker, as you can see here in the container script name. So when I run this, you'll see an example of what I'm talking about. So Packer is talking to us at this point about what it's doing with Docker to spin up a new container, run all of the scripts that we specified in that Packer directory, that ensure that we have all the tools we want on all of the worker containers, because remember, this is the base worker. And that involves running apt-get and installing a bunch of packages. Once we also sort of clean up the environment once we've actually installed all the tools we need. So this takes us a couple of seconds because it's installing all the apt packages, it's installing Python, it's installing a few other things. But once it's done, you'll see that we saw this provisioning with Ansible message. So now what's happening is we're running the playbook for this particular container type on the container itself. And so you can see if you look at the Ansible invocation right here, this is the answer to your question. The Packer Ansible plugin has taken care of creating a private SSH key. I'm just going to keep this on the screen for a second. Has taken care of creating a temporary private SSH key for us and creating a temporary inventory you can see here, right? And that inventory essentially treats the container as if it were a remote host. And so does that answer your question?
Yes, it does.
Great. Okay. So from here, what we're doing from Ansible's point of view is just running a playbook on a remote host. That's it. And so now we can do all of the tasks that we defined in that playbook that I showed you earlier. So if we go to build and Ansible, here we've got wherever the base worker is. It might be just actually within the role itself, I imagine. So there'll be a default probably, right? Which will run through the various tasks that have to be done on the workers. And again, this gets a little complicated when we get into what they actually have to do, or why they have to do it. What's funny is that the actual tasks that are being done are effectively quite simple. They are things like make sure a certain file or a group of files is in the right place, make sure certain directories exist and have the right permissions, make sure certain software is installed and it works. But basically, those are the kinds of tasks that are being done. Oh, and setting up users and groups and all that stuff. So the gamut of what Ansible does. So all of those tasks are being done. Various files are being placed into various places, and so on, in order to install and make sure that all of the dependencies that Rugged has work. Now, once that's all done, and you'll see there's quite a bit of it. There we go. It's possible that with the base worker, we actually don't have any separate tests. Let me just take a look here. Looks to me like that's true because once that's done, we tag and we push the Docker container to our local container registry. What I'm going to do is take a quick look at what the next one is. So the monitor worker is the next one in the list. And this will be what I can do because it's make is I can actually use Docker monitor worker as our make target and container will actually set all the other variables the way that I want. This is fine. So running the Docker, the monitor worker target next, we'll go through a similar process as the previous one, where what I'm doing here is I'm actually downloading the Docker image that I just pushed to our local registry, right? Because I've said in that JSON file that this container will descend or start from that one. So it ensures that we've got it, which of course, because it's on the same environment, it's already there, and engages in the same kind of thing, right? Makes sure that the rugged code base is in the right spot, makes sure that all the files and so on are in the right spot, and that all the permissions are right. What I want to show you, though, is the next thing that happens, which I think is the cool thing, which is here, I think, which is that, yes. So what we're doing here I'm going to scroll back up and catch it before it goes away. So once we've actually, once we've put all the dependencies in place and make sure that they all have the right permissions and that all the moving parts are on the container, we call a new Ansible playbook. And this one is the monitor worker test playbook that just is a set of criteria to say, does this container actually have all the stuff on it we think it does, that we thought we just put there? Does it actually work? When I take this container and put it into a running environment, how can I tell if it's actually going to work or not? And so you can see here, we have various tests. Some of them are to try to start the actual application that runs on the worker, right? The process that's a supervisor, that is managed by supervisor. It's a Python worker process that wants to process incoming metadata requests and stuff like that. We look at the logs, we make sure they look correct. We look for various other information. Oops. Have I stopped sharing by any chance? Suddenly I cannot hear you.
Sorry. Yeah, you can share again.
Interesting. All right. I'm going to head back to share my entire screen. All right.
Okay.
Is that working?
Yes, it is.
Wonderful. Okay. So we are looking at the output from trying to start all the various components, and we are ensuring that it looks it looks the way we expect it to, or if it doesn't, we know why. So for example, some of these containers, when we run them in isolation, might not be able to connect to some of the expected other components in a multi-container running tough server. That's okay. From the point of view of these kinds of tests, those aren't failures. That's just what we expect. So we look at the different results. We make sure that the processes we expect to be running the way we want to run them actually run and actually start successfully and actually declare, yes, I started up successfully. This actually works. We clean ourselves up. We throw away the instance of the container that we were testing with, and then we push the image to our container registry. And so what's nice about this pattern is that you have a consistent and clear way to define your expectations for the target state, right? The end state. And then you can verify the end state. And you're using Ansible to do that. Our tests are not written in some other language that our DevOps have to learn, right? We are not pulling in some other test for infrastructure like RSpec or anything like that. We are just using Ansible itself to test the results of its own work. This is like in math class when you check your own work. So that's why I'm excited about the pattern. Of course, it gets more and more complicated as we go down the line, and we can test some more of our container images, but that's the basic process here. So I'm gonna start another one of these, and while it's running, we can just watch it. And I'd love to know, because we're at 12:43 now, if there are any questions about how this all works, or what we're doing, or why I think it's cool.
Yeah. The chat is open for any questions.
Yes, questions into the chat.
Well, I guess while we may be waiting for questions, yeah, I just wanted to say, sometimes should I say, using Ansible for tests like you have it in this scenario is, how do I put it? Ansible is not always the first point of call for tests. In the developer world, there are probably many libraries or Python libraries or
that's right.
application libraries that are suited to that. Yeah.
Sure. People don't think of this as, but my point is simply, look, you actually already have enough information. You can use assert statements. You can organize your Ansible, your test playbooks very similarly to the way you organize your provisioning playbooks, right? And this way, the folks creating the Ansible playbooks don't have to learn or worry about competence in a new tool, they can just use the same tool. So what's nice about that is now you've got some consistency, right? We've got, if we should take a look here for just a moment, I just have overlapping windows, right? We can see this is, this is a very typical Ansible project setup, right? Each of these is what we would expect. We have, when we look at our roles, we've got, the usual metadata, tasks, templates, and defaults, etc., right? You can do all of this just using Ansible. So it's not, this is what I'm saying, is this is not the usual way that I've seen anyway of people using Ansible, but I really like doing it this way because it means I've got a sort of self-contained environment that can test itself, right? It's very easy for me to pass that along to somebody else or to get somebody else to contribute to. I don't need them to learn another tool, and I don't need to have an argument about with them with which one is going to be the best tool, which on many teams that I've been on is one of everybody's favorite conversations to have is, well, if we need tests, we should be using Bruno, or, well, I like Playwright, or, whatever your favorite test is. A lot of the very fanciest of the test frameworks that I see these days um, are geared towards testing front-end web functionality, not this kind of back-end DevOps functionality. And so what that means is either people don't write good tests for their DevOps functionality, and it's flaky, or sometimes it fails and no one knows why. And it then becomes unreliable. Or they try to sort of add this sort of more back end scripting kind of testing to an existing tool like Bruno or Playwright or anything else, which never really works well for me. It always feels like an afterthought. It's not really a first-class citizen, and it's not really what those tools are meant for. So the tools themselves feel like they're not very happy. You're kind of fighting with the tool to get the job you want done. What I like about a framework like this is that you're already in it. You're using the tools you would need to use to diagnose any problems or troubleshoot. It's a really easy way to tell, do I actually have a way to tell whether this thing is working or not, short of deploying it into a real environment and then undertaking all of the risks that that might have, right? This is a way to kind of trap your component under glass and say, okay, does it actually work? Before you put it in front of, whatever trials or tribulations the real world has in store for you. So at least you're prepared, and at least you know that it's going to work. The other nice thing about this, which I hadn't had the chance to get to, is now that once you have all of these tests defined in a suite of tests, the same way that people have unit tests for their code, when you have a problem in a production environment, you can set aside the tests that would prove to you whether or not every aspect of this very complicated system is actually working the way you think it is. And so you can just run the same tests that you ran in development against the production environment, as long as they don't, that there's huge caveats there, because you have to make sure they don't introduce uh, fixture data, right? Test data that's not meaningful in a production context and stuff like that. So you have to be careful about how you design tests like that. It's often the case that you would want to have a set of tests for production that sort of leave everything alone. So it seems like Derek's got something to say, so I'm just going to read Derek's. I would agree, Dan. I think unusable still most commonly. So I think unusable should have been the word Ansible. I believe that's a typo. And I think what Derek's trying to say is that Ansible is still most commonly associated with infrastructure, ops, and config management. We're starting to see more use cases like this, leveraging Ansible to increase reliability and improve the developer experience. Exactly so. And this, Derek, of course, is what we meant when we said DevOps back in 2008 anyway. What we meant was we should be using all of the sort of tools and mindset that the developers have about being able to about testability and repeatability and reliability. We should be learning those lessons in the ops world. Of course, the reverse is also true, and there's lots of things for developers to learn from ops, like writing code that is testable and creating engineering processes that are repeatable and reliable and all that good stuff. But for me, what's cool about Ansible, especially because, of course, the killer feature of Ansible that we're relying on here is idempotence, right? It's the fact that Ansible is engineered at every step of the way. You have to work pretty hard against it to make it not be idempotent, and it gets very mad at you when you do, right? Ansible really wants to leave things alone, leave them in a state that is the same as the state that when you started with. And so that to me makes it a really great tool for testing, right? Because that means you can leverage that functionality to ensure that the thing you're testing hasn't been altered by you testing it, right? So you sort of try to get around the uncertainty principle. So anyway, that's what I think is cool about this technique and this framework that we've come up with. This is not the only project that we're doing that is open source. There's also a hosting project for Drupal sites called Aegir, which many folks on this call that I can see that I know of are quite familiar with, where we have also, for example, built an Aegir Ansible collection, which contains a lot of tests like this so that it is testing itself every step of the way as it deploys various infrastructure on which to host Drupal sites. So that's generally the idea here. I don't think this idea should be particularly revolutionary, and yet, as Derek agrees with me, it doesn't seem to be the most common thing we hear about. It's very much the thing that ops is supposed to be, right? Reliable, repeatable. Um, you need to have confidence in your infrastructure. You need to know that the thing that you think you just built has in fact all the characteristics that you meant for it to have. And so a great way to do that is to build a set of tests that let you prove to yourself, okay, the thing I just did worked. And that's basically my presentation. Any further questions or feedback? I'm not hearing any and I'm not seeing any. Well, that's delightful.
Yeah.
Olu, did
Okay.
you have any other things to share or suggest? I have one more thing I
Yeah.
can talk about if people want to see it.
Okay. I think we're running out of time. We just have it's
That's
already
also
12,
fine.
yeah, 12:52. So yeah, so just as a takeaway from the presentation, I understand that we are all some we're all coming to Ansible from different places. For some it's new, for some for others it's not new, but well, one of the most should I say useful words that we will learn over time when it comes to Ansible is the word idempotent, right? So if you're new to Ansible, you can look that word up. It's the basic reason it's the basic selling case for Ansible. Yeah, so
Sorry,
I think we have a question.
yes, sorry, so the idempotence word?
Yes, yes.
Yeah,
So I said for those who
yeah,
are new, the
yes,
concept is if you saw while he was doing the demo, there was you saw green on the screen and then you saw yellow. That's Ansible kind of gives you the idea when it's green, that means it recognizes that the system is already in that state, and when it's yellow, it shows that it's making a change.
that's right, that's
Yeah.
right.
So I
Yes,
think there's a
and
question in the chat. Yeah.
yes, idempotence is really important exactly for all the reasons we just talked about. You want to know when you're making a change, and you want to be able to run your processes and know that the state that you were in at the beginning and the state you were in at the end is the same.
Yeah.
Um,
There's a
Manvinder,
question from Marvin.
Manny is
Yeah.
asking
Yeah.
about,
Yeah.
does it work with Kubernetes as well? So there's no reason you couldn't use an idea like this with Kubernetes. Presumably, so the problem is the word it in your sentence. Because remember, this is just a set of tools that have been built around the development effort for rugged, which isn't a Kubernetes, which doesn't target Kubernetes. I think what you might be asking is, so remember, what I'm showing here is using the Docker plugin for Packer and the Ansible plugin for Packer. So if we were deploying, for example, Kubernetes workloads, then I'd have to go and look and see if Packer has a Kubernetes plugin. I'd be shocked if it didn't. That would allow you to generate and deploy Docker workloads on various kind of container workloads, rather, on Kubernetes. The reason we're using Packer, and Christopher and I were talking about this yesterday. One of the reasons we're using Packer is because it supports so many different backends. So not just Kubernetes, but possibly also virtual machines instead of containers, or even bare metal servers. But if it's okay with you, Olu, could we let Christopher unmute?
Yes, I unmuted. Yeah.
He already has.
Christopher,
Thank you.
go ahead.
So what we're doing here is building Docker images. What the Drupal Association, who are the primary production users of this application, are doing is hosting it on Kubernetes. They have a Helm chart that builds some images based on these images, but then does things like injecting some environment variables that are specific to their particular deployment. So this is used in Kubernetes, but we don't target it directly. And as Dan said, part of the reason that we decided to do this with Ansible was specifically like with Ansible and Packer versus just using Docker files for this kind of configuration, was specifically because we use Docker in our local development environment. We use it in this particular deployment with the Drupal Association. But we are in discussions with other organizations like Packagist, who host packages for the broader PHP community. And if we were to look at hosting an instance for them, likely the likelihood for scalability is that we would actually not use Kubernetes, but rather look at something at sort of a bare metal level to get the kind of performance we would need. Because in that case, it would scale from 1.5% to 2% of websites that Drupal supports to 60 or 70% of websites that are built on PHP. So the level of the scaling in that case would require the kind of flexibility to decide not necessarily to be bound by doing it with Docker directly. And this way we can just switch Packer to use a different build mechanism. And we would be able to generate, AMIs if we wanted to host it on Amazon Web Services, or ISOs that we could install on bare metal or whatnot. There you go.
So if you're Manny, if you're looking at thank you very much, Christopher. So if you're looking at that rugged code base that I had up here, under the build directory, under Packer, you will see that we have a Docker directory where we're defining all of these container types. And if you look at any of these JSON files, you'll sort of get the sense for how Packer manages this. You'll see that we are sort of saying this is going to be an image, right? Packer itself has a whole set of functionality where it'll accept other information in this JSON format about building those kinds of other things that Christopher just alluded to, whether it's VMs or whatever other sort of fungible infrastructure you want to get into. So I do highly recommend, if you're interested in this sort of thing, that not only are we talking about why Ansible is kind of great here, we're also really talking about Packer, which you can find by looking up HashiCorp Packer.
Okay. Thank you all for stopping by, and like to express. Yeah, so I think we just got a note from Packer. It says, I've heard that Ansible is useful for setting up computers to run Kubernetes. I'm certain you could use Packer to create Docker images to run in Kubernetes pods. I've also had it is possible to run VMs in KTest using KubeVirt, and
Right.
you could certainly run Ansible on those VMs.
Right.
Yes,
Because remember, this is what we're showing here is really just a framework. It's just a particular way we're doing this kind of thing. It's really the pattern that I wanted to get across to people of using Ansible to test the results of its own work. The underlying infrastructure is something one could change for any other project. So really my hope here is that folks will look at Rugged as an example and adapt it to their own local use cases when it comes to this notion of trying to test the work you just did.
Yes, so from I mean to the first comment, yeah, there's a lot of interest in the industry these days in virtualization with Kubernetes as a
Right.
result of license changes on VMware. So
And all that
you
stuff.
could
So yeah, there's lots of
also,
different Matt, I think
yeah,
that's Matt Parker. Thank you, Matt. There's lots of different solutions within, especially in the Kubernetes space. Yeah. But the underlying pattern could still be the same, right? My point was simply when you're building your images or whatever the thing is that whatever your artifact is, it's still this pattern of I build the thing now before I publish it or push it to a registry or whatever that is. I I test it in isolation and make sure it actually behaves the way I think it is. In other words, the thing I just built is in fact the thing I think I just built.
okay. We're about a minute over one, but we'd like to express if there are no other comments or questions, we'd like to thank everyone for joining in. Thank you to Daniel and other colleagues from Consensus Enterprises. This is our first and certainly not our last. Hopefully, with the with the number we've had here, we'll be looking at organizing another virtual session in the next few weeks. We might have someone lined up already, but please stay tuned to your emails and please read our emails. We try not to spam you all. Thank you for joining, and yeah, see you soon.
Thanks, folks. And thank you, Olu, for organizing and managing all of this. That's a really important discussion in the community.
You're welcome.